Hey, ladies and gentlemen, today we'll be looking at the power rule of differentiation. So we'll be looking at the power rule of differentiation. So what is the power rule all about? The power rule simply tells us the principle of differentiation. That is simply the basic. Obviously, apart from differentiation from first principle, we have the power rule. So the power rule simply tells us that if you have a function f of x such that f of x is equals to x to the n power, what we do with differentiation is we actually minus 1 to the power and multiply the function by n. So f prime of x will simply be n times n times x to the n minus 1. So what you do is you multiply by n and you minus 1. So this is what we have with the power rule. Now we are going to go through some examples so we'll clearly see how the power rule functions. Because notice that f prime of x here is when we have differentiated it, so we can still write this as dy dx to be equals to n x to the n minus 1. So when you see f prime of x in differentiation, just know the function have been differentiated. So let's go through some examples. Let's say we have a function x to the fourth minus 9x squared plus 6, and let's say this function is equals to y. If we are to find dy dx of such a function, what we do is we differentiate each term separately. So we differentiate x to the fourth separately and minus 9x to the x squared separately plus 6 separately. So dy dx, where you differentiate y, is giving you 1. Since we are differentiating with respect to x, differentiating y will give us dy dx. So it will be equals to differentiating x to the fourth power. What we will have is x. Remember, the power rule tells us you minus 1 to the power, so it will be 4 minus 1. And verifying the power rule again, will be multiplying by the power, so we'll multiply by 4. So that is what it will give us when differentiating x to the fourth power, minus you multiply by the power. So negative 9 times 2 gives us negative 18x, and you minus 1 to the power from the power rule, so minus 1 plus differentiating. Now take note of this: differentiating a constant in differentiation gives us 0. So differentiating 6 is a constant, we will have plus 0. Now we are going to tidy this up by simplifying what we have there. So dy dx will simply be 4. 4 minus 1 is 3, so we have 4x cubed minus 18x. 2 minus 1 is 1, so we simply have 18x here, because 18x to the 1 is 1 and 0 is. So this is what we have for the when we differentiate y equals x to the fourth power minus 9x squared plus 6. We end up with this. Now let's take another example. Let's say we have y, the function y, to be equals to 2x cubed minus 1. What will we do with this? what we do is differentiating y gives us 1. Since we are differentiating with respect to x, it will be dy dx equals to. Now look at what we have here. We have 2x cubed. So the power rule tells us that we will minus 1 from the power and multiply by the power. So what we will do is we will multiply by 3. So it will be 2 times 3 x raised to the power 3. What does the power rule tell us? The power rule tell us that we have to minus 1 from the power. So 3 minus 1. Now differentiating a constant in differentiation gives us 0. So we have plus 0. To tidy this up, we have our dy dx to be equals to 2 times 3 gives us 6 x. 3 minus 1 gives us 2. So at the final analysis, we have 6x squared. So let's go through the next question. What if we have our y to be equals to x? You can just pause the video and try this and try to solve this, and you come and check your answer later. When y is equals to x, you should look for dy dx. So what we simply do is, if you have paused the video and come back, the solution of this is dy dx to be equals to, we look at x as x to the 1 power. So dy dx will simply be, you multiply. So let's consider there's always a 1 here to be n. So this is 1 times 1 x to the 1, and the power rule tells us that we minus 1 to the power. So this is going to give us 1 times 1 is 1, and 1 minus 1 on the power is 0, and x to the 0 is 1, because from our basic algebra in mathematics, we know that anything raised to the power 0 is 1. So this is just 1 times 1 from here. So x to the power 0 is 1. 1 times 1 is 1. And at the final analysis, we have 1 times 1, which is 1. So differentiating x gives us 1, which is a constant. Let's go to, I think we'll have this. Y is equals to x squared minus 7x. So you can still go ahead and pause the video and you try this, then you come and check the solution later. So welcome back if you pause the video. Let's go through this rapidly. So differentiating this, we have dy dx to be equals to, we multiply by the power. So this is 2 times 1, because there is a 1 here, even though it's we usually don't put it, x squared. And what do? We minus 1 to the power, minus, what do we have here? 7 times 1, because we consider that there is a x to the raised to the power 1 here, even though, so when it's raised to the power 1, we don't put. We'll see from the previous question we had up. So negative 7 times 1, x raised to the power 1 minus 1. So to clear this off, we have actually 2. So 2 times 1 is 2, x, 2 minus 1 is 1. So we just have 2x minus 7, minus 7 times 1, it gives us 7. X to the 0, because we have 1 minus 1 over here. So x to the 0 is 1. So we actually have 2x minus 7 to be our dy dx. So we have come to the end of this our video. If you find it helpful, just press the like button, subscribe and share so you can get notified for all new videos that will be post in this channel. Thank you.